Hi everyone. I think it's a little bit impossible to wrap up all the things you've done in a couple months or weeks in 5 minutes, but let's try. Um, in this presentation or lightning talk, I'm going to talk about the things and insights about my recent findings and latest work on a rule-based classifier. I've called it as Rule Mutation Classifier, or as short RUMC. This is a rule-based classifier inspired by evolutionary methods, specifically some kind of genetic operators like mutation. To just give you a short background on these kind of algorithms, rule-based classifiers are some type of machine learning algorithms used for data classification. They fall under the same category of machine learning. They share some similarities with evolutionary algorithms. This specific one tries to classify the data based on some evolutionary approaches. Actually, earlier this year, I proposed a data classification algorithm called RUPAC. Initially, I wanted to use that as a platform to introduce another one based on the things I've learned in this class, but the things didn't go well, and the outcomes was disaster. So I tried to switch to another algorithm, which is RACER, as you can see in the left side of the poster. RACER is the basic algorithm I've used to introduce RUPAC. So the process of RUMC is quite similar to what I proposed, what the RACER algorithm is, but there are some kind of better steps in that. Actually, these rule-based classifiers are all based on if-then statements. RUMC also involves generating n number of rules based on if-then statements, which n is the number of records in the dataset. As you can see in the left side of this poster, each record of data can be represented as a binary string in form of zeros and ones, which 0 means false and 1 means true. Now imagine if we have any kind of dataset with high number of features and a small number of records. That's what we call high dimensional, low sample size datasets. As each class, as these kind of classifiers will be built upon the total number of records in dataset, we will run into some problems. So it makes sense if we tweak those initial rules to make them generate better predictions on the unseen data points. RUMC has 9 steps, as you can see in this middle picture here. About half of those steps are dedicated to that purpose. So I'm trying to improve those initial steps by adding 2 extra steps to the RACER. Step 4 and step 6 in this picture are specifically designed by me. Step 4 is the rule mutation phase, and the step 6 is the primary generalization phase, which I'm going to explain shortly about how they actually work. The rule mutation phase is actually inspired by the evolutionary operation of mutation. So first it identifies all 0 bits in each rule, and then we'll make copies of that rule. For instance, if we have 4 0 bits in each rule, the function will create 4 copies of that rule and then tries to flip those 0 bits to 1, calculate the fitness, and if it gets a better or a higher fitness, then it will use that specific rule and again iterate over that other rules, and to ultimately get a better rule so that it can predict the right classes better. On the other hand, we have another phase called the primary generalization phase, which is step 6 in this picture. There are some similarities with the previous step, but the approaches are different. In this step, we do not create any kind of copies. We just focus on one rule on a time. Combining these 2 steps with the other previously designed steps, we can get a better overall accuracy for the algorithm. As you can see, I tested that the RUMC over 40 different datasets, which was initially gathered on the OpenML website and UCL Machine Learning Repository, and compared it over 20 other well-known classifiers. Classifiers including naive-based decision trees, those are listed on the bottom of the middle column, random forest, bagging, of course, the RACER and RUPAC. Main objective was to get a better overall accuracy over RACER, which, as you can see, I've got almost 3% improvement. But I've also get a better average accuracy over RUPAC. RUPAC L was the one with the highest average accuracy I proposed on my previous work. So I also got a better overall accuracy on that, which was a favorable thing. There could be some sort of future directions on that work. There are some arbitrary parameters I've used in the code, which can be dynamically adjusted over time. And also there there are some discretization methods used to discretize the data in this algorithm. As I told you, this type of rule-based classifiers only get categorical data to do the process. If the data is not categorized, they've used some type of discretization methods. I've used information gain. We can just focus on other kind of discretization methods like NDLP or some other things to check if we can get a better results or not. And I think that's it. I've also just submitted that on arXiv on Tuesday, and it's now available online, so you can just check it out if you are interested in the work. And there's a GitHub page dedicated to that, so you can also check that on my website or at the bottom of that page. That was all. Thanks for listening. So please, if you have any question, just go ahead. Seems nobody have any question.
So, are you doing everything with mutation, or is there any kind of search operator that would resemble a crossover?
Crossover, I'm not sure if you have any kind of crossover in this algorithm, but the rule mutation phase, which is the fourth step in this algorithm, is inspired by the mutation of the genetic operator mutation. The process of flipping each 0 bit to 1 results in a mutated version of that rule. So,
So could you imagine a crossover operator with this representation?
Crossover operator, it can be possible. I've never thought of that, if it's possible or not. But you can make a lot of different types of rules based on the initial rules. But you need to just check if it's going to result in a better outcome or not. That could be a future direction, yeah, crossover. I expected to get more questions to answer, but that's fine.
Thank you for posting it on arXiv.
Thank you so much. Yeah,
Thanks again.